Welcome to the webinar, Turbid Well Water and What to Do About It. I'm Cliff Tryans, Director of General Public Outreach for the National Groundwater Association. It is my privilege to introduce our presenter. Richard Throne is a master groundwater contractor, the highest level of certification available to water well system professionals. He operates his own business, Mantella Well Drilling in Lakeland, Minnesota. Richard also is former president of the National Groundwater Association. During the presentation, feel free to type questions in the question box. At the end of Richard's presentation, he will answer your questions. Also at the end of the presentation, we will make a handout of the presentation available for downloading. This webinar is provided by the National Groundwater Association and the Rural Community Assistance Partnership with support from the U.S. Environmental Protection Agency. So without further delay, I'll turn it over to you, Richard.
Thank you, Cliff. Welcome to Turbid Well Water and What to Do About It. Again, this is one in a series of webinars by the National Groundwater Association with support from the U.S. Environmental Protection Agency. When you turn on the faucet to fill a glass from a household well, you're likely to see crystal clear, sparkling water. There's a good reason for that. The groundwater is a good filter for water, and the groundwater is usually of better quality than surface water due to the percolation of the surface water going to the aquifer through varied layers of soils, which filters out many of the contaminants. When the water from a well is turbid or cloudy, meaning it has suspended matter in it, the water may be cause for concern. The turbidity could indicate a breach in your well system. It's measured by shining light through a sample and quantifying the suspended particle concentration. The more particles that are in a solution, the higher the turbidity. It's important to note that while turbidity correlates with suspended solids, measuring turbidity is not the same as measuring total suspended solids. Total suspended solids measurements are gravimetric, which quantifies the mass of solids suspended in a sample, performed by weighing the separated solids. Such breaches could affect the water's clarity, taste, and odor, and present a health risk. The suspended matter in turbid water can be inorganic matter other than plant or animal, such as nitrates, nitrites, phosphates, manganetes, things of that nature that are indicated in this slide. It also can be organic, as indicated in this slide. The suspended matter in turbid water can be inorganic matter other than plant and animal, or organic. The size of the suspended matter can range from microscopic to coarse grains of sand. The upper slide shows a filter membrane capturing small 0.5 to 50 parts of material, parts per million of material in its filtering process, where the bottom photo shows an actual well screen that has gaps of 10 to 20 thousandths, filtering out the coarser sands to provide a water quality. The size of the suspended matter can range from microscopic to coarse grains of sand again. Of greatest concern are disease-causing microorganisms such as E. coliform, which is a fecal or sewage matter possibly coming from manures, failing sewage systems, things of that nature. There is also Giardia, which is a disease caused by flagellant protozoum cysts, generally found in mountain streams and the likes. There's also Cryptosporidium, a parasite in unfiltered, untreated waters such as rivers, lakes, and reservoirs. In 1993, Milwaukee had an unusual outbreak of Cryptosporidium due to the sewage being discharged into the lake, not enough wind to rile it up and break it down. The plume migrated south of town to the intake of their fresh water system, creating a great outbreak of Cryptosporidium. Sometimes a breach in the well system can be at or near the surface. Examples are a well casing with holes in it. In this slide, I would say that this is probably due to overchlorinating the well and not flushing it properly with water, because chlorine is quite corrosive, and as you see, it burned a hole in this casing. The reason I say this is because the hole is above the grass line, so it can't be acidic soils creating a condition above the grass line, or the grass would be dead. A broken well cap such as this one can allow vermins such as spiders, ants, and others to go into the well and contaminate it. It could be a missing well cap. I've seen mice and snakes and every other things, including earwigs. Do not stack or store wood piles near a well, because earwigs look for a place to harbor in a warm spot in the winter and a cold spot in the summer, which is the well. Or an unsecured well cap. A unsecured well cap could be a non-sanitary cap used for many years because it's just a slipover cap, and that was the best we had. Now they've developed a sanitary well seal cap. In this right photo, it shows two blue plates compressed together with bolts, and then black unit in between is a rubber gasket being compressed to keep out all the contamination sources. On the left of the photo is the conduit connection, where a conduit would be put over the wire to protect it from lawnmowers, weed whips, and vermins getting into the well. Also not shown in the photo are 1 to 2 screened vents, because a well will breathe. As the water is pumped in a well, the drawdown will cause a negative pressure without any type of vent system. So there is a vent system built into the cap as well. Sometimes a breach in a well system can be at or near the surface, such as a lack of the seal of the top of the casing, as we just indicated. Bacterial contamination from the surface can also seep down along the casing in the borehole, from the backhoe and or the drilling process, and loose material in the annulus not sealing it off properly or being grouted properly can allow bacteria coming from the surface to migrate to your aquifer. Other sources can also be a crack or a hole in the well casing. Turbidity also can be due to a failing septic system, which has overloaded the groundwater with untreated and inadequately treated sewage. Shallower wells could be more vulnerable to a failing septic system due to the limited casing lengths. Minnesota Well Code states that any well with less than 50 feet of casing is considered a shallow well, which then requires twice the isolation or separation distances from any source of contamination. Other times, turbidity is related to well construction. On larger diameter wells in the old style of drilling by a cable tool drill rig, which is basically a cable going up and down with a chisel bit on it, has less impact on the aquifer. Then mud rotary came available, which uses a bentonite clay material to pump down the drill hole as they're drilling. And if you look at this photo, up on the top, you see a black hose with a loop on it. That comes from the mud pump down the center of the drill rods to the bit, so that it removes the cuttings and secures the borehole until the casing can be installed. Between the two employees with the light blue shirts, there's a tan chute right there. That's the drill mud coming back out of the hole, carrying the cuttings, keeping the borehole clean, cooling the bit, and removing any debris from the borehole. On the left is a red item there with a pile of mud below it. That is called a desander, removing the cuttings from the borehole and the receiver tank so that you're not regrinding the materials and advancing the hole as quick as possible. As you can see, that could be a contamination source. So it's required that all our water in the drilling process be of a potable source, chlorinated to about 200 parts per million of concentration to keep the borehole as sanitary as possible. Air rotary came along, which is a high air pressure going through either a drill bit or a air hammer, introducing oxygen into the water and crevice formations that can activate or increase iron bacteria, sulfur bacteria, and the likes of other materials that may be in the well, including moss and other manganese, irons, things of that nature. After a well is drilled and installed, it must be developed. Well development removes loose materials resulting from the drilling process and leaves the borehole more clean, stable, and permeable so that water flows more freely in the well. Proper well development can sometimes make a poor well into a good one in terms of water quality and water production. I feel this is the most important part of the drilling process, assuring the customer and the driller of the best possible well. The first steps towards a solution to turbidity is to test the water using a certified drinking water test lab. Many well system professionals can help you with this selection. The lab can determine whether there are any disease-causing microorganisms, and that could provide clues to their source. Also, before considering water treatment for turbidity, a well system professional should inspect your well to determine the causes, with such things that we've just discussed with bad caps, holes in the casing, settling around the well, and lack of or broken conduits. This could also include using a camera to inspect the well for cracks, breaks, holes, and leaking or cascading water from a bedrock crevice. It's also better to treat the cause of the water quality concern, particularly if it presents a health risk, than to simply treat the result. An inspection can determine whether the well has a breach, is dirty and needs to be cleaned, needs to be developed or redeveloped, or is being impacted by a failing septic system, as was discussed earlier. I had a well in Lake Elmo she called me to because of a turbidity problem. I got there and the well casing was rusted real bad, not as the one in this photo with the fingers showing through, but it was rusted extremely bad. And I asked her, have you been chlorinating this well? And she says, yes, because of our iron problem, we've been chlorinating about once a week. I went up and I kicked the casing lightly with my toe, and the casing fell over. Because of the corrosive action of the chlorine, it had completely ate out that well casing at the surface, so what was left down below? The process was abandonment of that well and redrilling a new well to replace the well that was bad. If water treatment is necessary, turbidity is reduced or eliminated by a combination of coagulation, which is to form a mass and dispose of with filtration, with some type of filtration, flocculation, which is like a wool type filter to filter out the suspended materials and dispose of properly, and filtration, including paper, sands, and things of that nature. And it's the most common approach. Different types of filters include a cartridge sediment filter, which is installed in the service line before the water taps, not before the pressure tank. Reason being is that if the filter is put in prior to the pressure tank, and I've experienced this numerous times, then what happens is as a cartridge becomes clogged and there's a demand for water in your house, the pump will start. Many wells are 4-inch in diameter with a 3 3/4-inch pump in there, so there's a limited amount of space between the well casing and the pump motor where the water comes past the motor to the intake of the pump to cool that motor. We sometimes have frozen conditions in Minnesota and Wisconsin that would obstruct the pump from pumping water into the home, such as a filter before the pressure tank. That pump cannot move water, therefore that's the cooling process, and it will burn the motor out in as soon as half an hour of running without moving water past the motor. I always say match the filter and cartridge with the flow rate of your pump. There's various flow rates, 5, 7. Most of ours around here are 10 to 20 gallon a minute flow rate systems. Keep in mind that a smooth cartridge would be a low volume, and that would be probably in the 5 micron area. Even on this cartridge showing in this photo here, that filter is still designed with that pleated cartridge in there to be about a 10 to 12 gallon a minute at 20 microns. So that would give you a better flow rate and a longer life with the pleated type filters. There are smaller ones like the one in the picture here, and there are larger ones, twice its size, 4 times its size, whatever. With replaceable cartridges, there's also a manual backwash style that has like a cyclone in it, and it circulates the water around a stainless steel filter, and as that becomes clogged, there's usually a red handle plastic valve on the bottom. You just open it up, it's been piped to the drain, and it'll flush itself, and occasionally it would have to be removed and flushed to get all the debris off of it. And now there's even a beautiful one out there for the young ladies that I deal with that can't unscrew the cartridge filters, and that's a sediment cartridge filter that's run by a 9-volt battery with a 1 to 30 day programmable program in it, and they really work great. When you get into larger volumes and more requirements based on the amount of turbidity you have in the well, a backwash sediment filter like this would be probably used. It's about the size of a water softener or larger based on the flow rate and the demands required of that filter. I had a well that we drilled over in Roberts, Wisconsin several years ago. And the water was crystal clear, but if you set that water glass there about 20 minutes, the lime would settle out of that water, and it was 26% total dissolved solids in there. So in that instance, the filtration people put in a filter such as the one you see in this photo, large enough to handle the volume of water and take out the amount of debris that was in that water suspended. Another one that's quite common to a lot of people is the reverse osmosis, in which water passes through a semi-permeable membrane to remove suspended and dissolved solids. You'll find these quite often underneath the kitchen sink, keeping in mind that this is a low volume system generally used for drinking and cooking purposes only. They do make larger ones, but that comes with the pocketbook too, is to whatever flow rate you desire and how much money you think you can spend on these units. If turbid water contains microorganisms, filtration is important because turbidity can impede water disinfection. Filtration and disinfection are often used in tandem, with filtration first, then disinfection. It's very hard to disinfect without filtering out the suspended particles. This is an ultraviolet water disinfection system. They're quite good, and again, they come with a price tag with them based on your flow rates and volumes that you're requiring. When considering a filter, compare the product specifications to your water test results to make sure it is designed to treat what you need to be treated and at your desired flow rates. About the sixth one down under perimeters, you'll see turbidity less than 1. The required maximum contaminant level, MCL, is 1 NTU. I didn't know what it was, so I looked it up. It's Neometric Turbidity Unit. There can be also another number which would have the following letters FTU. That's Formation Turbidity Unit. Those are two units of measure for measuring turbidity in water. Also consider whether you want to treat all the water coming into the household or just water coming out of certain taps. My dad had a unique situation. As he became older in life and city water became available, he plumbed it into the home, thought he was doing the right thing. The next morning, my mother got up and went in and took a shower and barely made it out of the bathroom. Why? Because of the chlorinated water in a confined space and her having a acute case of asthma. So Dad had to put in a special filter to take the chlorine out of that water so that she wouldn't have those conditions again. I also am working on a case right now, believe this or not. This young man has to have special filtered water in their private water well or anywhere because he's allergic to water. Yes, he's allergic to water. They have to filter the water to a certain degree for him to even bathe. When he goes for an overnight at a friend's house, he has to take his bottled water along. He has a condition where he can't even be out in the rain because of the particulates that are in the rainwater affecting him, and he breaks out with massive hives from foot to head. And it's a unique thing. At first, I thought she was giving me a little bit of a line, but as I checked it out further, this is a very uncommon thing, but it does happen. This makes a big difference in the system you choose based on what you need to filter it for and what you want to spend on a filter and what your end result would be at your faucet. We also would like you to consider visiting wellowner.org to find out more about useful well owner tools, including a private well owner's hotline, a private well owner tip sheet, online well owner lessons, and more free live and recorded webinars. Don't forget to check wellowner.org for other online lessons if you have questions like, what should I test my water for? We've been trying to discuss that. Now, what should I maintain how should I maintain my well? How can I help keep my water safe? What should I do if my well floods, which has been a great concern recently down in the south with all the flooding that's going on? And how do I get water treatment? And what should I know about getting a new well? If you're replacing an old well, please abandon that with a licensed contractor to prevent that from becoming a conduit from surface to aquifer, because if you don't do that, that well, that old well, could become an avenue or a conduit to the aquifer to contaminate your new well. So it makes common sense to abandon the old well and get it out of the loop from becoming another problem. We thank you for joining the webinar, and I know there will be some questions. So let's go forward with that, Cliff.
Thanks, Richard. Yeah, we do have some questions. The topic seems kind of cut and dry, but when you start to get into it, you find out there's more layers to it than one thing. So the first question has to do with someone who has an issue with cloudy water. He says, most of the time my water is clear, but sometimes after heavy rains it gets cloudy. Does that mean I have a breach in my well system?
That could be a yes and no answer. Let's go with after a heavy rain. That could be involved with some thunder and lightning. If the house is shaking, the ground is shaking, and this could cause in a bedrock type well for debris to break loose. And in a screened well, it could also happen if there's a lot of iron or other mineral in the well. The other thing I have of concern is that if you do encounter this, it wouldn't hurt to run a water test on it for nitrate and bacteria. Nitrate being an indicator of source of materials from the surface as well as bacteria. I had a situation in Spring Valley, Wisconsin, where spring snowmelts and heavy rainstorms would create cloudy water. They were located on a big bluff above the Crystal Caves, if anyone knows the area, and the stream bed was down below them, a couple hundred feet below them. We, in investigating, found out there was crevices in the bedrock, so when the water come rushing down the creek, it would raise up and get into those crevices and migrate over about 300-400 yards over to this person's home. Obviously, we had to seal off the old well and drill a new well below that area, putting in a casing through those crevices and cement grouting up that borehole to prevent contamination from getting into their aquifer. Very good question.
By the way, you mentioned the thunder and lightning and the vibration in the ground. Are there other things that could cause that? For instance, like heavy construction, or you know, any even an earthquake. We hear a lot about earthquakes these days with a lot of the hydraulic fracturing stuff that's going on. But are there other things that could cause disturb the ground to create turbidity?
That's a good question. We had some roadbed replacement up in the Stillwater area, and during that process, on the very top of the bluff, one of the homes had turbidity in the water. We filtered the water because it tested clean and clear, but with all the packers and the earth-moving equipment working below them, it disturbed the aquifer. And about a month after they completed that roadbed construction, the well went back to normal, and they actually, I understand, took the cartridge filter out. Other things with earthquakes, based on how you're located. In other words, in Minnesota here, Alaskan earthquakes years ago affected our waters and collapsed some sandrock, bedrock wells here. And I understand that this bedrock can go all the way down to Alabama's and down south. The other thing is that in areas that have clays, in other words, out in North Dakotas where they're doing a lot of oil and gas wells out there, this doesn't seem to be the problem because that material out there is of a clay shale absorbing type materials, where in Minnesota our lime rocks are very rigid and carry this wavelength across very quickly. When they had the tsunamis in the ocean recently, it impacted even in the United States here. Within a few hours, that tsunami put a pressure across the ocean waters that came from California to Florida in a matter of, I believe, about 3 hours. They saw a fluctuation in the big diameter wells providing water to cities because they have sensors in those wells, and they could see a fluctuation in that water from that tsunami. So even though we think we're on solid ground, it's a unique system we have below our feet.
Very interesting. Well, we have another question. You referenced the potential relationship between failing septic systems and turbidity. Somebody wants to know, how do I know if my septic system is failing? So what would be the signs to a well owner that they might want to get that septic system checked?
Well, the very first one is if there's a backup or a slowing down of the sewage in the home or leaving the home. Another area is if out where the septic tank is, it's getting very mushy or a smell, or you can see a grayish looking material. There are other systems called drain field systems or mound systems. We've had a lot of rain here recently, but if your system was failing, a lot of times it'll start leaching out the banks or onto the lawn in the discharge pipe area. In other words, the drain fields are a series of pipes upwards of, say, 60 to 100 feet long that have gravel underneath them that the sewage is supposed to percolate in. The gray water should percolate into. If the grounds become too saturated, or that bedrock that's supposed to percolate this material out becomes too saturated or gets scummed over, then the sewage will surface. And that's a good indicator of an area that's soft, grayish looking, a smell to it. It doesn't look normal, even though we've had a lot of rains, and there seems to be just this weird looking area. Get a sewage professional to check that out.
Okay, thanks. Somebody has a well development question. The viewer says, I may be getting a well drilled. Is well development standard operating procedure when a well is drilled? And how can I be sure that the driller develops the well?
That's a very good question, and I would hope that all well drillers would be proud of the work they're doing and develop that well out to its best so that the customer is very satisfied and you can walk away with pride that you've developed that well out. In any case where you have any doubt, have them put that in writing that they're going to develop that well out. Keeping in mind that some wells in our area here, we can develop them out in a half hour to an hour to get that well completely flushed of all the drill cuttings and the debris that was caused during the drilling process, and allow that well to breathe or provide water at its greatest rate. The thing is that it's like anything else. Get it in writing, ask the question, and that's, like I say, the most important part of the well. Anybody can drill a hole in the ground, but to be able to develop that out to provide a volume of water that's clean and clear at the volume you desire or greater than that volume is of utmost importance.
All right, thank you. You also referenced well inspections, and someone wants to know, how much do well inspections cost?
Okay, that's kind of a loaded question, but let me answer it the best I can. It's based on what you want it inspected for. Now, Wisconsin has a specific sheet that we use that's required by the DNR for the inspection of that well. And Minnesota, each state should or may have, or your county may have a requirement for well inspections. And they could be anywhere from, I've heard, as low as $50 to $150 without parts or anything like that. And then when you get into, like this morning, I just did a basic well inspection, and I believe that was $150. But then when you get into other well inspections where they want some kind of well water testing, that's another issue. It could be just basic nitrates and bacterias. It could include nitrate, arsenics. It could include lead. VOCs, volatile organic compounds, where we've had some leaching of products from past industrial use of the land at landfills, and it's gotten into our water table, which in some cases can be filtered. Other cases it has to have city water brought in. But that can go from a very minimal to the VOC tests are in $300–400 range. But again, it covers like 480 different chemicals that would be possible in our area. So the well inspection itself generally is, say, $50 to $250 based on what's included in it or what's required by the local units of government.
Okay, thank you. So there are several different approaches to getting treatment for turbidity. The questioner wants to know, how do I know which type of treatment for turbidity is appropriate for me?
That again would go back to having the water tested to see what the turbidity is. Turbidity could be, like I said, it could be some CO2 naturally occurring in the water. It could be iron bacteria, sulfur bacteria. It could be other products, manganese, uh, cascading water in a well. Like I said, down by Prescott and St. Croix River Valley here, we got water cascading from an upper aquifer to a lower aquifer because of the uncased section of the well. And that can cause turbidity. And it also causes a buildup of lime on the water pipe that supports the pump called the drop pipe and the electrical wiring. And so any movement of the pump starting can break some of that stuff loose, and that can come up through the water. So they use a whole house filter on that one, similar to that water softener picture we had in the slide presentation.
Okay, thank you. Here's a question. So this relates to bacteria. It says, does UV disinfection kill all levels of coliform bacteria in wells? Does UV have limitations? The Commonwealth of Virginia well regulations limit use of continuous disinfection unless geometric means of 10 samples is less than 100 colonies. So basically, I guess they're getting at the are there any limitations to UV effectively getting rid of coliform bacteria?
The limitations would be based on the size of the equipment and the amount of product you're trying to filter out. You have to match those two to get the end result of the amount of water you want. And keep in mind, any and all these units require maintenance, and without proper maintenance, they can overload and create even more of a problem, because if you get an overload into any one of these filters and it breaks through, now you're going to increase the problem tenfold, hundredfold, whatever. That's where I would go to my experts. I'm not in water quality treatment in our company because it's a vast area. So what I do is I go to the experts and I take them this sample of water and I say, our customer has this issue here. What are my options for taking care of this situation? And generally I talk to 2 or 3 different people, so I get a rounded solution for this problem. And again, with these bacterias, water quality in Minnesota can change up to 4 times a year, I'm told. And so keep this in mind, no matter where you're located, that there's a potential for water quality to change several times a year. Based on, in Minnesota, we've got, of course, the frozen season where there's no recovery to our aquifer. We got the recharge time in the spring of the year with snow melts. We had no snow melt this spring, but we did have heavy rains in July. So now we've had that extra surge of rainwater going down through the percolation process of supplying the aquifer. So that changes the mineral content and whatever else may be in that water. So keeping that in mind, you have to design a filter that's not only going to cover the bases now, but what happens if we get this overload? Will it be able to handle that as well? And then be aware that you need to maybe service that unit more frequently based on these potential changes. And it's a education process and a learning process, but we have to match what we've got and the potential that could happen with what our end result requirements are, and select a unit properly.
Okay, thank you. Here's a question. Is turbidity always a health risk, or can it sometimes just be a nuisance?
I would say that's a 50-50. In other words, when we talk about the Prescott, Wisconsin area where the cascading waters create this buildup of the lime and it breaks loose and comes through, that's a nuisance. It's not coming from the surface, it's coming out of the bedrock. Other times there can be CO2 or oxygen in the water that's naturally occurring. Other things like the screened well that we had there, sometimes with a lightning thunderstorm, that can shake the earth and cause the filter cake around the screen to move a little bit and let some fines come through. And in those cases, that's generally a nuisance, where other times, based on the surrounding conditions, it could be a health issue, and that's what needs to be determined by a groundwater professional.
Okay, thanks. Okay, this question says, I don't have a filter for turbidity, but I do have a water softener and a tap-mounted carbon filter. Can turbid water mess up my other water treatment devices? So I guess they're wondering if it can foul, the turbidity can foul up the other systems.
Yes, based on the amount of material coming through. If it's a minimal amount and it's from time to time, generally the backwashing systems of the softener and the changing of the tap-mounted carbon filter would take care of that. One of the problems I have with the tap-mounted carbon filter is that a lot of times people forget about how long they've had them on there, and or mom and pop are at home, and now during the summer all the kids come home with their kids and their grandkids. And the next thing you know, you've got, instead of 2 people using that faucet, you've got 10 or 15 people using that faucet, which can overload it and create an issue. But on the water softener side, generally what you can do is, if you're concerned about the turbidity creating a fouling of your water softener, you can change the timing, whether it's volume of water or time clock mechanism. You may have to contact your water conditioning professional to do this for you, but you could change that so you get a backwash. Many softeners have a manual regeneration or an extra deep cycle regeneration, or whatever terminology your manufacturer puts on that. And quite frankly, I've got a little iron in my water where I live here in Minnesota, and I use an iron removal salt, as well as about every 6 weeks I go down and push an extra deep cycle for regeneration of that softener out of the norm, because it's just my wife and I, meaning that if we were to get an overload into that softener and we don't get it completely removed because there's a timed water or time clock mechanism in these backwash systems, and if it doesn't flush it enough to get all that out of there, we may only have backwashed 80% of the softener, not getting 100% use out of it, and it's going to become, over a period of time, overloaded, and then it's going to be non-functional. So by me putting it into an extra regeneration cycle, this allows that softener to have an extra cycle to backwash it 100% to make sure I've got total use of my units.
Okay, thanks. Here's another question in reference to well cleaning. You mentioned well cleaning. How often do I need to do that?
Well cleaning is a different than well development. Well cleaning is usually a scrubbing with some certain kinds of brushes or drill bits or whatever, and well development is the pumping of the well either through a pump or air lift to clean the well, to clean the debris out of there from the cleaning process. Well development is the removal of the debris after you've knocked it loose. And well cleaning, whether it be chemical or mechanical, should include well development to be a complete process.
Okay, another person wanted to know, is there other types of debris that accumulate in my well over a period of years?
There can be on certain wells. We get a water moss in some of our wells in this area, and it's non-harmful, but it can build up a mass in there and break loose, creating a turbidity in the water. There could be other non-harmful types of products that can grow in there, like I mentioned, iron bacteria and sulfur bacteria, and they can foul things up a little bit too. And they're non-harmful, but they can create an aesthetic changing value of your water quality. And there's a lot of different things that can happen in a well. Like I said, the lightning and the thunder and the earthquakes and earth-moving equipment, things of that nature, an explosion somewhere, someplace. You had talked about the fracking of the oil wells, and in certain areas, when they frack that, if there's crevices close to the surface, that can migrate or has the potential to migrate over and maybe create a well with a condition with turbidity or other things happening. Years ago, we were drilling a well about 200 yards away from the neighbors, and as we penetrated through the upper limestone, there were crevices in there due to the aged condition of the limestone, and the winds conditions in the well were of a nature where it actually sucked and with our 250 psi of air pressure in the drilling process with the lower pressure rigs, it pushed the foam over and it came up up through the well casing and out the well cap in the neighbor's home. And that was due to the interconnecting crevices as we penetrated through that area to get our well down into the deeper aquifer for a better quality of water for the new customer, but we had to go over and clean the other well out. How that can happen is not only the high air pressure of the drilling rig, but it also can be in the conditions of the well. Along the river bluffs and where the bedrocks are, in the old days, there would be a lot of open hole. Minnesota now requires us to put a casing all the way into the water-bearing formation to eliminate these potentials for the well to be blowing and sucking air. And what I mean by that is under a high pressure air condition, generally the wells are blowing air out of them when there's crevices encountered in the borehole. When you have a low pressure move through, and we call those Alberta clippers in the winter when these storm fronts move through out of Alberta, Canada and come flying down through here, the well can suck cold air down the well and create a freezing condition or rile up the well with a turbid condition.
Okay, thanks. What is the most common breach in a well system that you see causing turbidity, and why do you think it is the most common? Does it have to do with the well itself or a lack of maintenance by the well owner?
I think most of the turbidity problems are the lack of maintenance by a well owner in the integrity of the well cap. We saw some pictures on the screen of some broken well caps, rock over the well casing. I've seen it. I've seen it all. I was just on one the other day that the well casing was so rusted and corroded, and she said that the water didn't seem right. And hang on, folks, here we go. I said, why is the dirt disturbed around the well casing? She's, well, and then I saw the two chains at the front door. They would let their two dogs out there. The well casing and the cap had been hit by the snowplow and was cracked, and they were allowing their two dogs to go out and pee on the well casing. Other times, snowmobiles, earth-moving equipment, four-wheelers, lawnmowers break the well cap, or somebody backing into it with a vehicle, break the well cap, and now you have this ability for ants, spiders, worms, earwigs, snakes, all that to go down that well and create a riled, turbid condition. The one I was just on this morning, the second job I was on, I lifted the well cap off, and it was an old style well cap, and it wasn't even secured. And it was full of grass and spiders on the top. And he says, well, my water's had some cloudy look to it occasionally. And I said, well, who took the cap off? Well, I hit it with the lawnmower and a bunch of grass went down in the well. So I think Mother Nature is the least culprit. I think the well owner is the biggest culprit because of lack of maintenance and understanding how important it is to keep that well sealed, because that's where your potable drinking water is coming from and it affects your health.
Okay, wow. That's good lesson there. Another question. I wasn't aware of grouting wells. I think you said some wells are not grouted. Why is that? Also, for those that are grouted, does the grout go the entire length of the well?
Wow. Okay. Very good questions. The long and short of it is not all wells are grouted. One is because of the requirement of the code. Two is if you're driving a well casing like a sand point at a cabin, down into the earth, and it has a screen on it, or you put a screen in. Generally, those aren't grouted. In some cases, the state code requires a portion of that borehole when it is drilled with a rotary rig and not driven like with a hammer or a cable tool rig. Then that initial borehole, which could be 6.5 inch with a 4-inch casing in it, to have either a bentonite or a cement grout in it. And again, some of your local codes require partial grouting of that borehole, and some require entire length grouting of the borehole. And it's based on the formation you're drilling in and the special well construction areas like I have here, where in some states they probably wouldn't require grouting. We always say when in doubt, grout. And so where we have these contamination zones, we drill a bigger diameter borehole and we grout it in to be sure that we're eliminating any conduit from surface to aquifer, so contamination cannot migrate down.
Okay, thank you. Here's a question again about treatment. If I'm going to install treatment for turbid water, why wouldn't I treat all the water coming into the house instead of just at certain taps?
Well, that again is something you have to decide on. Do you want whole house filtration? Do you want the outside faucets treated for that? And because that comes with a price tag. Say that you have a 15 or 20 gallon a minute pump to provide water to the whole household, the irrigation system and the likes, and to be able to put a filter in to accommodate that volume. That would be a pretty good size filter. Over in North Oaks here in Minnesota, I've got some 25 gallon a minute pumps over there for these big homes and their irrigation systems. They put in whole house filters there because the iron is so heavy in the well that it turns the sidewalks, the driveways, the house, the grass brown from precipitating the minerals and the debris out of the water onto those units. So they do whole house filtration for that, and those filters are generally 2 foot in diameter by 8 or 9 feet high because they have 10-foot ceilings in these big homes. And there's one home over there, the doctor has 5 of these cartridge filters. He says he has $25,000 in filtration. So again, you have to determine what taps you want to use and which ones you don't. A lot of times people will do at least the kitchen sink, and if they've got a water conditioning unit, they generally will consider filtering all the water before the softener to protect that unit from being prematurely plugged. So you have to determine what your requirements, and again, how bad is the turbidity? Sometimes it can be minimal where you can just put in a small filter, but if it gets pretty heavy, then you're going to have a bigger filter, and it has to match the flow rate of your pump to give you the water and the pressure at your faucets that the system has been designed for.
Okay, thanks. We have a question about inorganic versus organic. It says, the viewer says, you mentioned inorganic and organic causes for turbidity. What are the most common types of inorganic causes for turbidity, and do they represent a health risk?
Well, as we earlier discussed, a lot of times the inorganic can be the building of the minerals, the leaching of the fine sands through a screen due to interruption and or a self-cleaning design. And generally those kinds of things are not of a health risk because they're naturally occurring in the earth. Generally, there's no impact from the surface to contaminate it with bacterias. Where, like I said, in the drilling process, you're rotating a mud up and down the borehole. And if you don't start out with a good product, you're not going to have an end product that's good either. But the turbidity generally can come and go, like we talked about the water quality. And again, there could be certain times of the year when it's affected by certain climate changes. Of course, in Minnesota, that's winter and summer, or outside influences. I hope that kind of explains it to you, but the inorganic ones, I'm not as concerned about as I am the organic, because generally organics are coming from a more surface-oriented level that could create bigger problems.
Okay, unless somebody sends in a question right now, that we've exhausted our questions. But Richard, I want to give you maybe one last chance if there's any parting advice you would give people who have noticed a cloudiness in their water. Just what would you recommend they do as a first step toward investigating that?
Well, if you had a something that came up suddenly, or something of concern, I always tell people to let their heart make the decision. And if it's something that could cause a problem with my health or someone else's health, like my granddaughter's or whatever, I would contact a well specialist, a groundwater professional, to check that over for you. Um, well drillers have been around for many, many years, and they understand the conditions of the local area. And I stay within probably 50 miles of home here, and I know the changing conditions. It changes from one side of my shop yard to the other side, but I know that. So when I have an issue in one well or another well, I can somewhat relate to it. So we always say that you should contact the well system professional and ask for their advice. And if you're a little concerned, seek out other opinions and get something where you feel comfortable with, and then decide what you want to do with it.
Okay, well, we want to thank you, Richard, for your excellent presentation. We want to thank all the viewers who participated. We will be providing in a few days a link to the recorded webinar, and you should see in the handout section a download for that turbidity presentation you just heard. The PDF is probably the most efficient download. And with that, I just want to thank everyone for this excellent chance to talk about turbidity, a very common issue among well owners. And I want to thank you and wish you a good afternoon.
Thank you very much for participating. Goodbye.